Welcome to Ask and Learn.
All right, so this time we're given this incredibly long message, and we are told that the cipher is going to be of the form f of p is equal to p plus k mod 26. Right, so that means our decryption cipher must be of the form p minus k mod 26. Okay, and so how do we go about figuring that out? Well, we're going to do a method that you've probably done by the time you reach this problem, where we look at the most common letters in this cipher. And in this particular cipher, the most common letter happens to be M. Okay. And so we know that M is going to be the 12th Okay, so M is the 12th letter, and we want to find K by taking 12 and subtracting a value of other common letters. And so I've gone ahead and tried some of these other ones. E is the first option, it's the most common. It doesn't work. T, A, O, I, N, S, H, and R are the other most common letters. And it turns out this cipher makes sense if we use I. So we'll take I equals 8. And that means K is going to be equal to 12 minus 8 is 4. So we're going to take this cipher and use P minus 4 mod 26 to solve it. All right, so the first thing is to convert what we have into the numbers, and that ends up being 4, 17, 2, 22, 24, 9, 9, 12, 6, 12, 8, 17, 23, 15, and 2, and then 4, 7, 25, 4, 17, 6, 8, and 7. On to this next row, so we get 23, 8, 6, 11, 17, 18, 15, 18, 10, and 2, 12, 22, 12, 17, 7, 12, 22, 23, 12, 17, 10, 24, 12, 22, 11, 4, 5, 15.8. Okay, and so this set is really just this here, so we'll move the JVSQ down a row as well. So things are a little bit more lined up. So if we have JVSQ and the QEKMG. Right, so JVSQ is 9, 21, 18, 16. And then the QEKMG is going to end up as 16, 4, 10, 12, and 6. Okay, so now we need to take the modulus, right, which really involves just subtracting 4 from everything, and then mod 26. So here we'll get 0, 13, negative 2, so this is going to be 24, 18, 25, 5, 8, 2, 8, 4, 13, 19, 11, negative 2, so it's 24, 0, 3, 21, 0, 13, 2, 4, 3, 19, 4, 2, 7, 13, 14, 11, 14, 6, that's negative 2, because that's 24, 8, 18, 8, 13, 3, 8, 18, 19, 8, 13, so 10 becomes 6, 24 becomes 20, 12 becomes 8, 22 becomes 18, 11 becomes 7, 4 becomes 0, 5 becomes 1, 14, 15 becomes 11, and 8 becomes 4. 9 becomes 5, 21. It's going to be 17, 18 becomes 14, 16 becomes 12. 12, 0, 6, 8, and 2. Okay, so now we can translate it back. It's very exciting. And when we do that, we get A, N, Y, N, E, S, U, F, F, I, C, I, E, N, T, L, Y. So any sufficiently. 0 is A, 3 is D, 21 is V, A, N, C, E, D. Now here we'll be cramming it in a little. I apologize for that. 19 is T, 4 is E, 2 is C, 7 is H, 13 is N. So we have O, L, O, G, Y. I, S, I, N, D, I, S, T, I, N, G, U, I, S, H, A, B, L, E. Now I can't quite fit it under there, but the 5 becomes an F, 17 becomes R, 14 becomes O, 12 becomes M, and then the 12 is M, 0 is A, 6 is G, 8 is I, and 2 is C. So we end up with any sufficiently advanced technology is indistinguishable from magic.